And good day to you all, and thank you for joining us today. I am Don Burke with the North Carolina Department of Environmental Quality's Environmental Stewardship Initiative, otherwise known as ESI, and I will be one of your moderators today. I want to welcome you all to this webinar on the Department of Energy's Lithium-Ion Battery Recycling Prize. Today's event will feature Lauren Lynch, Senior Mechanical Engineer, Battery Recycling Prize Technology Program Manager within the Center of Integrated Mobility Sciences at the National Renewable Energy Laboratory, otherwise known as NREL. Lauren will introduce Phase 3 teams for the Lithium-Ion Battery Recycling Prize. Today's webinar is a collaboration with the NCDEQ's ESI Quarterly Energy Management Series and the ESI Quarterly Hazardous Materials Roundtable Series. As I mentioned, Lauren Lynch will be assisting with the moderation. We also have presenters, John Schustrick, Trish Tran, David Young, Lauren Crandon, and we will introduce them in further detail as we go on. I'd also like to give out to a shout out to one of Lauren's colleagues, Rebecca Martineau, for assisting with today's webinar and getting everyone together. And I'd also like to give a call out to various ESI staff from NCDEQ's ESI that are helping with today's webinar. We have 3 of our interns from North Carolina State University, Caleb Gimperline, Tim Havens, and Bethany Suarez. They'll be joining us for background support. And additionally, Marcia Alaco, our ESI supervisor and EAS section chief, and Angela Barger, the ESI manager, will be with us today. Thank you all for assisting. Now, we would be remiss if we didn't thank the Waste Reduction Partners and the Land of Sky Regional Council for hosting this training on GoToWebinar. They have been wonderful partners for us as we have shifted so much of our outreach and training to an online format the past year and a half due to the pandemic. Terry Albrecht, Section Chief of WRP, has been a wonderful partner with these virtual ESI events. So feel free to check out the ESI events webpage. I've posted this in our chat box as well, and you'll see it on a few slides coming up as well. It's www.ncesi.org for both upcoming events and past events, which include the webinar materials. Now, just a few housekeeping items before we dig into today's topic. If you have audio issues and are using the audio through your computer, you could switch to your telephone. Just go to the audio tab in the webinar controls box and click phone. A phone number and code will then be shown for you to use to access the webinar. The call-in information is also in your webinar invite email. Now, we are recording today's session. The link for the recording and webinar materials will be posted to the ESI events website, among a multitude of other avenues for everyone to access. And again, that is www.ncesi.org. Feel free to use that webpage anytime to learn more about our division. Now, to prevent feedback, sorry, a little technical glitch there, not sure why. Now, to prevent feedback and unintended background noise, all attendees are muted. However, we want you to ask questions and share verbally. So in order to facilitate that, we have a couple of options for you. We will ask you to raise your hand when you want to speak. Be sure to mute yourself only through the GoToWebinar software using the little microphone button at the top of the control bar. It'll be red when muted and green when live. It should default to muted, and we can unmute you to speak. But to reduce time fumbling through the controls, make sure to not use your phone or computer to mute. Now, if you don't necessarily want to speak, but you still have a question or comment, which again, we highly encourage, please submit those through the questions box at any time throughout the webinar. Now, after each of the presentations today, we'll dedicate that time to questions. And at the very end of the webinar, when presentations are over, and hopefully after and during a roundtable session, you can pose any further questions that may come to mind. Now, for those of you who are not familiar with our program, well, the Environmental Stewardship Initiative is part of the North Carolina Department of Environmental Quality. It's a voluntary assistance and recognition program. It's been part of DEQ since 2002. Our 20th anniversary is next year. And it is administered by the Division of Environmental Assistance and Customer Service, otherwise known as DEACS. We are partially funded by an EPA pollution prevention grant. We're in Region 4, and promote environmental management systems to assist organizations in their efforts to continually improve their environmental footprints. We also encourage and facilitate networking and training events that allow for peer sharing between our members on a wide range of environmental topics. Now, if you are located in North Carolina and not yet a member and would like more information, please email Angela Barger, the ESI manager, or myself. You'll see our contact information on the bottom left of your screen. We would be happy to share more information with you and answer any questions that you might have. There's no cost to join, and all we ask is an annual report on the progress made towards your environmental goals. As you can see in the upper right on the slide, you've heard this before, you can access our website at www.ncesi.org. And here's a fun splash page that we put together. Angela, give her full credit for this, on our current members. We'd love to have you be on the slide if you are not already. I do know, looking at the registration today through GoToWebinar, we have a few of our ESI members present. Thank you so much for being with us today. And again, we would like to thank Terry Albrecht and the Waste Reduction Partners for assisting ESI staff by providing our outreach today via the GoToWebinar, and also their partners, the Land of Sky Regional Council. WRP and the ESI are, as I mentioned, both part of the North Carolina Department of Environmental Quality and the DEACS division, which has a mission to support pollution prevention strategies and is actively promoting hazardous waste and hazardous material reductions. Terry's contact information is on the screen at the bottom there. Feel free to reach out to him for more insight to the program. And we are very pleased to have the following presenters and panelists with us today. As I mentioned earlier, you'll see them listed. And it is my pleasure to introduce Lauren Lynch, who will assist with today's moderation. Lauren is the Senior Mechanical Engineer, Battery Recycling Prize Technology Program Manager within the Center of Integrated Mobility Sciences at the National Renewable Energy Laboratory, NREL. Lauren has been leading the Lithium Ion Battery Recycling Prize, a $5.5 million phase prize competition focused on identifying innovative solutions for collecting, sorting, storing, and transporting spent and discarded lithium-ion batteries. This from electric vehicles, consumer electronics, industrial, and stationary applications for eventual recycling and materials recovery. The prize is designed to encourage American entrepreneurs to develop and demonstrate processes that, when scaled, have the potential to profitably capture 90% of all discarded or spent lithium-based batteries in the United States for eventual recovery of key materials for reintroduction into the United States supply chain. Lauren, thank you for joining us again, as you are a vital part of our June 15th webinar, Health, Safety, and Disposal of New Power Sources. It's wonderful to be able to collaborate with you once again. And I'm going to shift the controls your way.
Great, thanks, Don. I appreciate that. And we should be seeing my screen shortly.
I can see your full presentation.
All right, great. Well, with that, I will get us started, at least with focus to the battery recycling price. Thanks again for that intro. I just want to lay a little bit of groundwork and provide some background information as to the Department of Energy's focus on some key issues and goals when it comes to the supply chain related to lithium ion batteries and some of the objectives and activities that the Department of Energy is hosting in order to address some of those issues. So the National Renewable Energy Laboratory is one of DOE's national labs, and we are leading the prize administration of the battery recycling prize. So this is a Department of Energy funded effort, but NREL is helping, manage and kind of lead those efforts. The Department of Energy's Vehicle Technology Office supports early stage research to significantly reduce the costs of EV batteries while reducing battery charge time and increasing EV driving range. So there are multiple sources of projected growth for EV and lithium-based battery products. I think we've all been experiencing some of these growths in these markets. And in addition, the Biden administration has laid out a bold agenda to address the climate crisis and build a clean and equitable energy economy that achieves some carbon pollution-free electricity by 2035. There are also multiple sources that project growth, both within the US light-duty battery EV sales and some of the consumer electronic markets. For example, the Energy Information Administration, or EIA, projects that US light-duty battery EV sales will reach 1.4 million by just 2030. And again, this is kind of outdated information, if you will, as there are multiple sources that are projecting higher growth based off of more recent numbers. So that global EV sales, it's expected to reach more than 20 million by 2030, and that was up from just 2 million in 2018. So this growth in EV sales, as well as that increased demand for consumer and industrial and stationary applications, are expected to double the demand for lithium-ion batteries by 2025 and quadruple that just 5 years later by 2030. Excuse me. So that demand for global production of battery materials such as lithium, cobalt, and then there are other critical materials like nickel, manganese, and graphite will also grow at similar rates, causing the supply chain constraints, some geopolitical and economic competition, as well as increasing vulnerabilities that threaten to disrupt the availability of these materials, as well as the cost of the critical technology development required to support such growth of these materials to support growth of these economies. So currently, lithium-ion batteries contain a substantial amount of cobalt, which is the largest material contributor to their cost. The National Renewable Energy Laboratory has forecasted that the demand for EV lithium-ion batteries will surpass those portable electronic lithium-ion battery demands by 2023. So again, there's a little bit more focus on EV batteries driving the demand for these critical materials. And 60% of the cobalt global supply is mined in the Democratic Republic of Congo, where some are worried about the political and business decision-making uncertainties. Cobalt is also considered the highest material supply risk for EVs in the short and medium terms, leading to the increased prices for lithium-ion batteries. There's also lithium, which has been the enabling metal for achieving high energy, high power density, and low cost for lithium-ion batteries. Unfortunately, the mining process for lithium can be damaging to existing ecosystems, and it also takes a long time, about 10 years, to develop new operations to produce a large-scale amounts of lithium. So unexpected increases in demand can yield price spikes as well. So lithium is critical to long-term sustainability of EVs, but it should not be a supply risk if adequate recycling is implemented. And that's where we're kind of tying it back to today. So there are some existing processes that exist today that can recover lithium, but they're currently too expensive and new methods need to be developed. And that's one of the issues, if you will, that the Department of Energy has developed strategic objectives to address. So this growth in demand for lithium-ion batteries for EVs and the other applications is expected to establish EVs as the largest end user of cobalt and lithium, which in turn could potentially create that cobalt and lithium supply risk. So about half of the material, excuse me, about 500,000 tons of battery materials are needed by 2025, and closed loop recycling can supply significant amounts of that demand material and can impact the material costs and availability. NREL analysis has shown that 90% of those materials collected and material recovery rate can potentially supply about 35% of those cathode material needs in 2030, specifically that lithium, nickel, manganese, cobalt oxide combination. So that'll help mitigate the potential lithium-ion battery critical material supply risks. DOE's Vehicle Technologies Office, or VTO, has also established other strategic program goals to reduce these supply chain concerns. There are 3 key aspects of this strategy, and they include lithium battery recycling research and development, and this is to reduce some of those cobalt and critical material uses and needs, development of low to no cobalt cathodes, and the lithium-ion battery recycling prize. So today, I'm going to provide just a brief overview of what the prize is, our focus, and where we are within the prize, and then introduce some of the teams who will provide high-level overviews of their concept solutions. And we're really hoping to gain some feedback from audience as to the team's plans to fully scale, because they are proposing solutions that, when fully scaled, will contribute to the recovery of lithium-ion batteries, and these will be fully commercialized business solutions that we hope are utilized across the nation in order to contribute to that 90% recovery goal. So the battery recycling prize, as Don mentioned, is a 3-phase prize with a total prize award of $5.5 million. Again, NREL is the prize administrators on behalf of the Department of Energy. So we're currently in phase 3 of the prize, where only winners of phase 2 were able to advance. And from phase 2, we only had phase 1 winners. So we've kind of been funneling down those concepts. And the teams continue to work hard. The Battery Recycling Prize is designated to motivate innovators and businesses within the U.S. to develop and demonstrate profitable business and technology strategies to achieve that lithium-ion battery recovery rate of 90%. So phase 1 of the prize was broken into tracks, where our teams focused on developing novel solutions to specific challenges associated with collecting, sorting, storing, and transporting spent lithium-ion batteries safely and economically for eventual recycling. Then phase 2 focused on validating those specific track concepts and building out the proposal to a full end-to-end concept solution. So one that moves the spent lithium-ion batteries from consumers to the recyclers and improves the economic viability of doing so. So in order to advance the track-specific concepts, teams actually develop partnerships to support all areas of the end-to-end concept solution to ensure they had the proper resources to implement an effective business solution and help work toward that 90% recovery goal. So in phase 3, teams are still encouraged to partner and work with others, but the primary objective is to now conduct a demonstration that recovers a portion of the projected impact that they define in phase 2. So the winning teams will demonstrate their ability to recover lithium-ion batteries at a pilot scale and verify the feasibility of achieving the end-to-end solution when that solution is then fully scaled. So at the end of phase 3, we will have 4 winners, where $2 million will be distributed equally among them in cash prizes. Teams would then hopefully apply those funds to help support successful implementation of that end-to-end recovery process for increased recycling of lithium-ion batteries at full scale, and they will be profitable businesses across our nation. So today we have 7 different teams. We had 7 different teams advance from phase 3 into phase 3, and today we have 4 of those teams who will be presenting and providing an overview of their solutions. So the teams again are working on a pilot scale demonstration of their full process, and that includes soliciting feedback to inform their plans to fully scale. So in just a few minutes, you will hear more about what 4 of the 7 teams have been developing, and we encourage you, our audience, to take advantage of this opportunity as it will inform their business development of the processes, and they will continue to work towards this 90% recovery rate in order to support building a domestic supply chain of these critical materials. There may also be additional opportunities for you as industry to partner with the teams and support an aspect of the business or the concept solution. And the teams may even be requesting, some additional feedback or support as to aspects of this end-to-end solution. So with that, I'm going to go ahead and pass it over. I believe we're going to be hearing from David Young first, who is lead of our Lee Industries team. They have been working on machine learning-based automated smart battery sorting systems. So with that, David, we should be passing to you.
I just sent the baton over to David. David, I see
Great.
your presentation. The floor is yours.
All right. Can everybody hear me?
Yes, you can.
All right. Thanks, everyone. My name is David Young. I'm presenting on behalf of Lee Industries and our smart battery sorting system. All right, so a little bit of background about our company. So our mission is to revolutionize lithium-ion battery sustainability by developing next-generation recycling technologies. And so we really have 2 main pushes at Lee Industries. We're developing a novel direct recycling battery recycling technology to be able to convert end-of-life batteries directly into usable battery materials. And our other push is our smart battery sorting system that focuses on automating the sorting process for end-of-life batteries. And I'll mainly be talking about this second technology today. So a little bit of background about sorting. It's not something that we tend to really think about when we talk about end-of-life batteries, but material in general. But for those who are in the recycling industry, they know how important it is to properly sort materials so that you have relatively clean waste streams for processing. And the battery industry is no different. So sorting is very critical. And just kind of to walk through the general process as it is today, you have these end-of-life batteries at the consumer, industrial level, and when they're at their end of life, they need to be collected. So you have businesses that collect these batteries, consolidate them, and either themselves or they send out to others for sorting. And these sorters need to separate different types of batteries. So you, for example, consumer electronics side, you may have alkaline, NiCad, nickel metal hydride, lithium ion batteries all mixed together, and you need to split those out because all of these batteries are processed differently. Once these sorters process these batteries and sort them into different categories, they are then sent to recyclers that can handle 1 or more types of these batteries to be recycled. And so because sorting is such an important part of this process, any inefficiencies or issues with sorting, the costs, those are all kind of passed downstream to recyclers. And so it is very important to have good sorting, essentially. And another aspect of sorting, where sorting becomes important, is safety. So, specifically lithium-ion batteries, because of such a high energy density of those batteries, there can be, risk of fires, risk of explosions, and so sorting is actually very important in separating out different types of batteries that may react differently or have different levels of safety concerns. You may even think about, your cell phone batteries that have been moving more and more to soft packaging, and making sure that soft packaging is separated from, harder packaging or larger packaging to prevent any sort of puncture of soft battery packs or battery cells. So sorting is, important for many, many different reasons. And let me talk about what sorting is today. I have here current sorting methods are ineffective. Really what I mean is that there's a lot of room for improvement. A lot of sorting is done manually today. Most sorting is done manually. So you have people who sit on the line and pick out batteries and put them in buckets, essentially. So this is, you can imagine, a pretty inefficient process. It can also be quite costly given, labor costs in the US and elsewhere. And so really, this part of the battery recovery process is really ripe for innovation and change. In addition, you imagine that there's probably some limitations to what, people can do if they're trying to sort quickly in terms of accuracy for battery sorting. So, definitely, there can be improvements in efficiency, in cost, in accuracy, all of these aspects that can improve the sorting process, make it easier for recyclers to recycle clean waste streams. So really where we want to focus on is how do we automate this sorting process to make it better. I'm just going to lay out where, we see automation can impact sorting at different areas along the battery recovery supply chain. So, for collectors, for example, collectors may want to do a bit of pre-sorting, right? An example would be lithium-ion batteries from non-lithium-ion batteries, because lithium-ion batteries actually have special transportation requirements. So they may want to automate some pre-sorting, separate those out. Also, you can imagine to improve the rate of collection, you want people to be able to have the convenience of putting all their batteries in one place, and having some pre-sorting to be able to, deal with that. It can be helpful. For sorters themselves, I kind of explained the major downsides we have to the sorting today. So automation can definitely improve on, cost, efficiency, accuracy, etc. And then even on the recycling side. So, I mentioned, we're working on a process called direct recycling. And direct recycling, because you're creating materials directly from those end-of-life batteries, you actually need very clean waste streams. So, for example, different cathode materials cannot be commingled together, or can be only commingled at a very limited rate. So sorting on this level can be very important as well to maintain quality of the incoming batteries into a direct recycling facility to create that additional value. And direct recycling really is a big push that a lot of folks are really going for right now, because it really adds a lot of value. You're skipping a lot of processes that can ultimately create battery materials by creating battery materials directly. So that's really kind of a big aim for a lot of recycling today. And sorting can really help with that by creating very clean waste streams that go into that process. And overall, automating sorting is really trying to push towards that DOE goal of obtaining 90% lithium-ion battery recycling by 2030. We think that it's a critical part to this process. I don't think we can do it without improved sorting methods. So I think this is something that requires a lot of focus and attention too. And we're very grateful for DOE kind of pushing this with the battery recycling prize to provide opportunities to work on these kind of projects. So let's talk about the solution that we're proposing and working on. So we call it the Smart Battery Sorting System. So it's an automated system that basically conveys batteries down a line, takes measurements of these batteries, physical, chemical measurements, computationally sorts them using their features, and then physically puts them into correct bins that can be consolidated to be sent to recyclers. This is a faster, more cost-effective method than manual sorting, and it can improve the efficiency of battery recycling as a whole. And here's just a design. You can see these batteries moving down the line. We're taking measurements at the start of the line. The batteries are then moving down the line as we're processing those analyses, and then ultimately, we're sorting these into different bins. And here's just an example. For example, if someone only cares about lithium-ion batteries, maybe they group all the non-lithium-ion batteries together, and then these are all lithium-ion batteries of different cathode chemistries that can be processed separately. So just to talk a little bit more about the critical features of this system. So we're really talking about three main components. You have this feature detection that takes these physical and chemical features of each battery and puts them into a computer system for analysis. We use machine learning to develop algorithms to better sort our batteries. So it can learn from the batteries that are out there and make better sorting decisions. And then we call it transportation. Physically putting those batteries in the correct location and then sending them out to the recyclers. One of the key features that we wanted to develop in the system is flexibility. So these types, I've labeled them just A through D. There can be, as many as you want within, something practical, and it really depends on the need. So, a collector may just care about, I want lithium, non-lithium. That can be, set in the machine. Some care about different lithium-ion batteries with different cathode chemistries. Some just want to separate lithium-ion batteries, alkaline, nickel metal hydride. Those can all be, tuned by the machine to sort those different types of categories. So we really want that to build in that flexibility for different types of use cases. And the machine learning allows us to continuously improve on the sorting. So as new battery types, shapes, styles become introduced, we can update these lines pretty efficiently to be able to sort for these new types of batteries. So it's a very adaptable, flexible system that really, seems to be needed based on the feedback we are getting from those that are doing sorting today. Another key aspect of the smart battery sorting system is the basically we call it a IoT or Internet of Things capability, where you have scalable data management and the ability to deploy new versions of the line software-wise pretty efficiently. So we have a centralized Internet of Things platform that we're developing that allows for cloud-based analysis of what are you sorting, how many types of batteries. You can get a lot of analytics from there, and then you can get updates as well to your line as our models continue to improve. So to talk a little bit about where we're focusing our initial attention on. So we're looking at the consumer electronics market first as our beachhead market. And we believe this is really where this automation solution can be deployed, immediately have a significant effect. And it's a fairly sizable market. You can see that over the next 5 years, we're going to be growing to about 150,000 metric tons of batteries to be stored a year. And on the right, you can see kind of a rough estimate of that sorting market value. And you're talking about 50 million plus. And just the sorting value itself not to mention, improvements in sorting having an economic effect on other parts of the supply chain, improving collections, improving recycling. But just the sorting itself, you're talking about a $50 million plus dollar market, which is quite sizable. And we believe that, the smart battery sorting system can have a real immediate impact on this segment of the market and immediately improve the ability to sort more batteries more economically. And just to talk a little bit about the impacts on the recycling rates, here's just an example of kind of more generally what the contributions we believe the introducing automation will have into the market. So you can see that we've kind of broken down these estimates into different categories. On the left graph here, we believe that the overall recycling rate will increase because you have better economics. Perhaps collectors can collect batteries more efficiently with better sorting capabilities. And then you have a lot of reinvestment or cost reductions that warrant growth or cause growth in the industry. We believe a large part of what will grow the market is better economics. So by improving the economics of recycling and recovery as a whole, we believe that more batteries will be recycled as a result. And lastly, just, this green section is just talking about added sorting capacity, right? So, as we continue to need more sorting, I think one of the big areas that we're going to need work on is how to sort more, right? Because I think we're going to run into labor issues. We're going to have to, maybe there's more localization. I think some automation will definitely help with that process. And just focusing and looking at the consumer electronics market, we believe that by, in combination with other technologies, our technology can contribute to, in the next 5 years, basically getting that recycling rate of consumer electronics to, upwards above 60%. And with the goal of course, getting to that 90% by 2030, we have to be very aggressive. Consumer electronics being a mature market really warrants us having a lot of focus on getting those batteries that are already out there recovered as efficiently as possible. So kind of a timeline of what has been done, what's being done, and what will be done. So in last year, we developed a prototype during phase 2 of the battery recycling prize. This was a proof of concept testing, and then drafting some initial business plans, doing some market research. That was all done last year, and we had a prototype that worked fairly well and actually was able to sort batteries at about 99% success rate. But this was done at a few batteries at a time, right? So in this phase of the competition this year, we're focused on developing a pilot scale system, and that's where we're at right now. So we're in the process of building this at a pilot scale to be able to process thousands of batteries at a time. We have capacity goals that are at several thousand metric tons a year. So really taking each line taking a big chunk of the processing capacity that's needed for significant sorting growth. So we're in the middle of that. We're developing a full business plan, to be able to, develop the sorting capabilities, work with collectors and existing sorters and recyclers to kind of develop this full end-to-end solution. We've been sourcing batteries from collectors and sorters to test on our line. So that's all being done this year. And next year, we plan on improving on that pilot line and really getting ready for full commercialization, being able to deploy these sorting lines across the country, developing resources to support that, so installation, service, et cetera, and then growing that network of partners to be able to push that solution forward. So that just about wraps up my presentation. Want to thank everybody for listening in. Want to thank the organizers for organizing this event. And if you have any questions, please let me know. You can reach me at my email contact here, or I'm sure we have Q&A in this meeting as well. Thank you very much.
Oh, thank you, David. That was wonderful. Great insight. Really enjoyed your presentation. And I did notice that we do have a few questions. Know if Tim or Caleb or Bethany, or y'all going to look at that?
Yeah, so we do have a couple questions if you have time, but the first one being, where would this sorting take place for the batteries?
So for this phase of the competition, we are basically deploying the pilot line at our facility, which is located in Blacksburg, Virginia. So for the pilot line, we're doing all the testing and validation of that scale there. And then in the future, we imagine partnering with existing sorting facilities that are spread around the country to develop a more localized sorting plan that really we are trying to leverage existing infrastructure and kind of growing or building on top of that to really implement the solution as quickly as possible.
Right. And then the second one is, how does your system get batteries out of consumer electronic products?
So that's a great question. So for a lot of the embedded batteries in consumer electronic products, we currently actually don't look at that. So the batteries will need to be removed, and for the most part, that's done manually today. And so those batteries will have to be removed from those consumer electronics before they can be processed. We imagine that in the future, as we're developing these processes more, there can be some automation there as well. But right now, that's not something that's being addressed at this time. So this line really processes batteries that have been already isolated from the products themselves.
Gotcha. Okay. Next one here says, are they accepting batteries from other companies for sorting, and then do they send them for recycling?
So the short answer is yes, and that's something that if whoever asked the question is interested in, they can contact me and we can discuss your specific situation.
Okay. And then one more, what is the plan for where the batteries go once sorted? Are IT OEMs aware of your project, and what has their reaction been? Same for MRFs.
So we have a network of recycling facilities that are already operational within the US that we are working with for those batteries to go to. So essentially, because the sorting actually is taking in not just lithium-ion batteries, but basically any end-of-life battery. There is a different facility or facilities that handle each of these types, right? So we have lithium-ion battery processors, we have a lead acid, we have alkaline. Those are all within the network of folks that are able to process the batteries that after we've sorted them.
Gotcha. All right.
Wonderful.
Back to you, Don.
All right. Thanks a lot, Caleb. And David, once again, thank you so much. I hope you can stick around. We'd love to maybe, just in case there's any other further questions later on, or possibility of a roundtable type discussion. But thank you again for your time and energy. It's very admirable what y'all are doing. I really appreciate it.
Absolutely. Thank you.
Thank you. And Lauren, is it appropriate to Lauren Lynch? Are we going to Lauren Crandon now? Is that correct?
Yes, yep. We have Lauren Crandon from Onto Technologies, and they've been developing a disk solution that deactivates, identifies, sorts, and cuts batteries for end-of-life processing.
Okay, Lauren, and I've set the controls over you. I see you received them, and I can see your full presentation.
Great, thank you. Excited to be here today. Thanks so much for having us at this event. Again, my name is Lauren Crandon. I'm a research scientist, research engineer here at Onto Technology. And our solution for the battery prize is, we've called it the disk solution. So this stands for deactivate, identify, we also sort and cut. So I'll start just giving a little background about the company. Our core business area is developing technology for lithium-ion batteries, so specifically direct recycling, cathode healing. We develop technology for battery deactivation, disassembly, discharging, and sorting. We have over 20 patents in these areas, so we work with strategic partners to license and scale up these solutions. We've been doing this a while. We were founded in 2004 by our current president, Dr. Steve Sloop. We're here in Bend, Oregon. And our facilities are pilot, some of the technologies still at that pre-pilot stage. And so here at Onto, we really focus our energy on a couple of specific challenges and opportunities to reduce the overall cost of the lithium-ion industry. The first being safe transport, and this is what we focused on for the battery prize. How do you move end-of-life batteries to a recycler safely? So we've developed technology to eliminate the flammability and reactivity risks that go along with batteries. And this really reduces the cost of shipping. So I'll talk a little bit more about that in the next slides. But the other main area of technology that we focus on is efficient electrode recovery. So we've developed what's called cathode healing. This is a direct cathode to cathode method, and we can produce high quality, low cost cathode material really efficiently. So I'll talk more about that as well. I just kind of want to highlight the risk that we're addressing with our technology. So every cell, even the dead batteries, carries some element of risk. So in this pack here, each of these cells has some risk that goes along with it related to the state of charge, but also things like state of health. I mean, there could be gas buildup or the electrolyte aging, could form lithium dendrites, have some corrosion that would lead to a short in the battery. And also, if you've stored batteries at too high of a temperature for too long, they could pose some serious risks. And so right now, the industry really only focuses on discharging batteries. So the problem with this, that does help, but it really doesn't address all these state of health challenges that we see with end-of-life batteries. And as you can see, even at this early stage, transporting batteries to recyclers already caused some major incidents. And so as we reach those numbers that Lauren Lynch mentioned earlier, we might expect to see even more of these accidents, and we really want to prevent that. Not only is there inherent risk in moving these batteries around at their end of life, it's really expensive. Dead batteries are still classified as Class 9 hazardous materials. So on the left there is a shipment that we received in our facilities. This is about 100 pounds of dead batteries, and that was over $3,000 to get it to us. So on the right, you can see this represents over half the overall cost of recycling, according to Linda Gaines at the Department of Energy. So this is a huge drag on the recycling industry, and it's really preventing recycling from becoming, making economic sense and becoming a cost-positive industry. So what we propose for the battery prize is what's called, again, the DISC concept. So we're working with environmental service providers, which already pick up some of these batteries from a number of industries. So we've collected electric vehicle batteries from buses, from car wrecks, We've also gotten in military batteries and consumer electronic batteries. So we've demoed all of those for the project. And once they reach a disk facility, they're deactivated to remove all those hazards. So now they're safe to work with, safe to store if need be. Then we identify the battery, and we also have an automated identification and sorting system. So we're able to initially sort out non-lithium ion chemistries like lead and alkaline, but also sort between lithium ion cathode chemistries. And then we do an automated disassembly or cut step, and we're able to separate the valuable materials from the batteries. I mean, really maximize the value in these end-of-life batteries. So the cathode material, because it's been sorted efficiently and we've cut it really cleanly, so this is high purity material, we can send it to the best recyclers. So for example, if it's a high cobalt battery, you might send it to a metals refinery and get a good price for it. For those low or no cobalt chemistries that we're seeing come on the market, those are great candidates for direct recycling. In the near term, we might send it to a different recycler, just try to fish out lithium or something like that. And in the future, OEMs may want their own material back, so we could certainly do that after it's been sorted. And we also get a really high recovery of other metals in the batteries. So clean aluminum and copper foils could be sold to a non-ferrous recycler at this stage. And the shipping for all of these materials is going to be really low cost. So I'll walk step by step through our solution. Deactivation, we can start with a charged or discharged battery, any state of health. If they're damaged, that's fine. Any chemistry or any format. So we can do individual cells, but we can also process larger modules and packs. So we put it through our system, and this uses carbon dioxide. So that's a green solvent to transform these lithium batteries into an inert material, basically. So this again removes all the reactivity and flammability. And in doing so, we're able to really reduce that cost of shipping. So instead of $2.49 a kilogram, it'll be more on the order of about 11 cents a kilogram. And here's some early examples of the patented process in-house. So these cells were taken from end-of-life bus batteries we got from Seattle. And the one on the top was fully charged. When we place it on under thermal abuse conditions, so heat it up, it, as you would expect, goes into thermal runaway and explodes. So this is what we want to avoid. And the same thing happens when you discharge the battery. So you've still got that flammable electrolyte in the battery, so there's still that element of risk, even though it's been mitigated somewhat. But that bottom battery there, we took a fully charged bus battery, put it through our system, and then we let it sit at a thermal abuse 500-degree heat source, and it does not react at all. So it's completely inert at that stage. So these are completely safe after we've processed them, and we've since in phase 2 and 3 of the battery prize gone ahead and processed larger batteries as well. So the next step in the process is identification of the chemistry. So we use rapid imaging and we measure other physical properties of each battery. So the picture up above was our initial small scale prototype for individual cells. And we've since improved or added a bigger prototype in our house, so we can even put full pallets of batteries and be able to identify the chemistry that way. And so this is a patented method, so we've been practicing this on a number of different batteries for quite some time here. The next step is identification. So we use a machine learning model to take all those properties that we've directly measured. We're able to determine the chemistry, and then we verify it with an inline elemental measurement. And this was our proof of concept sorters, so we were able to go ahead and bin those based on the chemistry that's been identified. The last step in our disk solution is to cut the batteries open. So we're doing this in partnership with Shape Technologies Group. So they're world experts in automated disassembly. And so we've come up with a really safe, high throughput way to cut these batteries and maintain the purity of the electrode material, make sure we get a high yield of material coming out, and make sure there's no accidents. So we've used this not only to cut open individual cells, but you could cut out modules out of a whole pack. We've done some of that. And you could also cut larger modules. You could also remove cells embedded in a device. So put together, all the steps of the disk solution really allow for high yield of all battery components. So in the upper right-hand corner, we get really clean aluminum and copper current collectors coming out. So that's one great product. The lower right-hand corner below that is our clean electrode material. So we've got a clean cathode there that we can go ahead and recycle further. We may also want to save things like the battery management system has value, and other pack or equipment components that could be recycled using other methods. And again, all of these, they've been treated, they're safe and inexpensive to ship to the correct recycler. So at On2, we process the electrode material using our cathode healing direct recycling method. So I think I have a little video showing our process has really allowed good separation. So we get very high yield of this stuff. And then we do direct recycling. I know David mentioned direct recycling. This is a cathode to cathode method. So we don't dissolve the material and separate out all the metals. We're actually able to process the particles as a whole, and what comes out on the other end is cathode particles that are ready to be put into brand new batteries. So here's an example of some material that we've processed, and you can see we're able to remove that binder, re-lithiate the particles, and get rid of trace metal contamination. So these are as good as new. And to show this, we've gone ahead and made brand new batteries out of this recycled material. And when we recycle it next to fresh out of the bottle material, we've got really good performance. And we're continuing to work on this with a number of manufacturing partners and using a number of different chemistries. So what we're working on now, we're working in partnership with Sandia National Laboratories. So we've sent them some of our deactivated batteries, and they are going to put it through their battery abuse testing system. So this is rigorous testing, including battery calorimetry, gas analysis, things like that, to really make sure that the batteries we're treating are completely safe. And then this is done in parallel with another program that we've got going, working with Lawrence Berkeley National Lab under the Cal Testbed program. So this kind of zooms in and looks at the materials closely. So have we really reacted all that residual lithium, and then on the back end, the material we've recycled, making sure that that is just as good as material made from mined metals and ready to be put back into batteries. So together, we're really validating our approach with these two programs, and we're really excited for that opportunity. So here's what a disk facility is going to look like. This is in progress. So the initial pilot will have a processing capacity of 1,000 tons per year of batteries. And this is a great solution. It's modularly scalable with the market. So as we see EVs really increase in volume, we're going to be ready to process them at their end of life. But also, you know, as they come off early, we might see some defects, recalls, crashes, things like that. We'll be able to handle it as the volumes demand. And so the idea here, to get to that 90% recycling rate of lithium ion in the US, is to start implementing these disk facilities at regional locations. So the pink dot there is our facility in Bend, Oregon. So we're modeling ourselves as the destination facility for right now. And we would start putting a disk facility in some areas that have a high volume of EVs is a good place to start. And then we'd like to keep adding these and really minimize the shipping distance of non-treated batteries. So we want to deactivate them before we ship those long distances. So that's going to cut down on cost and cut down on those accidents that we saw at the beginning. And then, of course, the financial analysis of this on the left shows the tonnage of batteries that we would need to process to get to that 90% number. And so we've mapped out how many facilities we need to do to get to that. And then the different colors represent the different cathode chemistries that we expect to see. These projections are based off Bloomberg from a 2019 report. And if you'll notice, as we go along, 7 years out, we're going to see lower and lower concentrations of cobalt. So this is a problem for some recyclers. For direct, that's totally fine. On the right here is the net revenue for the disk solution. So if we go ahead and process the disk solution and we sell everything for metals value, we're positive in year 1, and we can see that continue to increase in the coming years. If we add direct recycling on top of that, we can really increase that profit margin despite the lower cobalt chemistries coming on the market. We anticipate realistically we'd see a combination of the two. So depending on the chemistry and the throughput we're getting, we may do direct recycling on some batteries, but send the other batteries for metals refining. So with that, I'll just give a shout out to our team. Steve Sloop is our company president. He'll be available for questions after this as well. And I'd love to get a little shout out to Talon Swanson at Seattle King County Metro Transit. So he's been great to work with, and they're doing excellent work on electrifying their bus fleet. So that's been exciting to be a part of. And then just want to acknowledge some of our partners. The Department of Energy, EERE, helped us develop some of this deactivation technology, and we're working with Defense Logistics Agency on our cathode healing technology. And then for right now, I'll just, we're working with, again, some environmental service providers and cathode and cell manufacturers, so we really appreciate their support at this stage. So here's my contact information. Happy to answer any questions and look forward to hearing from you. So I will pass it back to you, Dawn.
I think you're muted there, Dawn.
There we go. I'm doing my mime imitation. Thank you so much for that insight. Wonderful. And we do have a question, it looks like.
Great.
Yeah, so how does the CO2 get into the hermetically sealed individual cells to render them inert for processing?
Yeah, for some cells, the pressure alone is enough to breach the cell, but we do have ways to, puncture the cell if needed safely for that CO2 to get in.
Right, and then we have one more. Can you provide more details on how CO2 makes battery cells and modules inert? Liquid CO2 under pressure, how long does this process take, etc.?
Okay, yeah, I think we're happy to answer some more details offline, but in general, we're really going after the active lithium here and the flammable electrolyte.
Okay. And then one last thing, how much more time does this process take than the normal processing of batteries, would you say?
The overall solution or the deactivation?
Deactivation.
Yeah, it's pretty fast. So I think it's on par or faster than what's currently being done.
If you consider.
Okay, cool.
Actually, I'd just like to chime in. Hi. I'd like to chime in. It's actually maybe hundreds of times faster than what's being practiced today, because if we start the clock when that battery is put in a barrel, class 9 barrel, and then shipped who knows where to be shredded under conditions that are going to produce kind of a mess, that could be weeks and days, maybe 3 months. So if, for instance, let's say we're fast forward into the future, you have an electric vehicle mechanic shop that pulls out a dud, they can put it in the reactor right there. So that's what, 20 minutes versus 3 months. So I think it's an interesting question because it has two different paradigms that we're looking at. We're looking at a whole new different paradigm here to deactivate prior to sending stuff out on the road. So it's an interesting question. I'm happy to discuss it. So thanks.
Yeah, awesome. I think that's about it. Back to you, Dawn.
Thank you so much. And Lauren, if I'm not mistaken, are we going to Trish now?
We can, excuse me, go to Trish because I don't see many of the Clarios team members on yet. So
Right.
Trish, if you're ready, we can pass that to you. And Trish Tran is from our Smartville team, where they have been developing distributed heterogeneous unifying battery facilities to reduce costs in the reverse logistics supply chain.
And Trish, this is Don. I see that Mike Ferry has joined you as well. If Mike has anything to add, feel free to unmute yourself, Mike, and we'll go from there. But Trish, the floor is yours, and I can see your presentation. And there we go. It's in full presentation mode.
Okay, perfect. Let me see if I can switch my screen because I think you guys are looking at a different screen than I am.
I'm looking at DOE Lithium Ion Battery Recycling Prize webinar. And now, yep.
Oh, there we go. How about now?
Yeah, it looks like the
Perfect.
appropriate one. Yep.
Great. Perfect.
Thank
Hi,
you.
everyone. So our company is called Smartville, and this is kind of our update and our overview for the Battery Recycling Prize. So to introduce myself, my name is Trish Tran. I am the project manager here at Smartville, and joining with me on the call today is Mike Ferry, our president. So stationed in San Diego, California, Smartville is a rapidly growing renewable energy company, and we're working to service, manage, and reuse lithium-ion electric vehicle batteries. Smartville is developing technologies. Oh, whoa. Sorry, there's something going on my screen right now. Oh, there we go. Smartville is developing technologies to utilize these batteries in a second life to provide inexpensive stationary energy storage for homes, businesses, and the electricity grid, while trying to empower a new circular economy for zero carbon energy and electric mobility. So our end-to-end solution really addresses 4 main challenges when it comes to reusing and recycling lithium-ion batteries, and that is the material collection, separation and sorting, safe storage and transportation, and dealing with the reverse logistics of lithium-ion batteries. So when lithium-ion batteries are collected and taken to our distributed heterogeneous unifying battery or hub facility, which will be stationed in areas with high lithium battery recycling needs. Our low-cost collection method allows electric vehicle end users and original equipment manufacturers to bring in bulk shipments of second life batteries or batteries that are no longer commercial ready to be serviced at our facilities. Our proprietary balancing and conditioning technology allows us to receive and work with lithium-ion electric vehicle batteries of different form factors, different chemistry, and at various stages of health. Once the batteries arrive at our facility, it will go through an assessment and screening process. Such process cycles the second life batteries to assess its current state of health, capacity, impedances, and just overall performance. This allows us to generate a battery aging data to identify the battery's remaining life with really high accuracy. The cycling procedure in our separation and sorting method effectively conditions any batteries that are still suitable for reuse while safely storing and preparing the remaining batteries for recycling. So at the facility, the second life batteries are stored for future reuse and transported to recycling if it's reached its end of life. The batteries deemed suitable for reuse will be integrated into an energy storage system to provide services to the grid. Remaining batteries at the end of life will be packaged for bulk shipment to recycling centers. So this portion of our solution allows us to use these second life batteries to its fullest potential before we de-energize them for recycling. So overall, our end-to-end solution aimed to handle all the lithium-ion battery reverse logistics at our distributed hub facilities. For our pilot validation approach, Smartville is deploying multiple distributed hub facilities to reduce the cost and create value in the reverse logistics supply chain, and by balancing, conditioning, and certifying lithium-ion batteries before repurposing them for secondary use or shipping them to recyclers. So the hub facility itself combines optimized logistics, grid services application, and second use resale to create a profitable, comprehensive hybrid repurpose and recycling method that works for really any lithium battery type. This end-to-end solution is expandable to rural and urban location as the market grows, and that serves some value to battery owners and recyclers. The hub facility aims to extend the second life battery's life cycle by more than 30%, provide a cost reduction in to grid energy storage by 50%, and can have a targeted battery recycling rate of more than 90%. So since receiving our phase 2 battery recycling prize award, Smartville has been developing our modular assembly battery, or the MOAB. So the MOAB is a 250 kilowatt hour rated energy storage system integrated with proprietary power electronics to balance and condition the second life batteries. It also serves as the fundamental building block for our distributed hub concept. So for the pilot demo, the Smartville has partnered with some of our battery suppliers, such as Renewable, to procure such batteries. And then the conditioning process will accurately assess the battery state of health to improve the overall battery's performance, and then also decrease the standard deviation in the multiple battery packs that is in the system, and also collect sufficient data to ensure future battery performance. The MOAB can be used for both front and behind the meter applications. And once the second life batteries have reached its end of life, it will be shipped to Spears New Technology Facility, our lithium ion end of life recycler partner. The on-site pilot demo will showcase said distributed facility, our distributed hub facility, in a smaller scale form. The installation includes 3 MOABs, 2 with second life battery modules, and then 1 with second life battery packs. The total power rating for all 3 systems is roughly about 300 kilowatt. And then each of our MOABs have a DC interface that allows the batteries and the modules to be balanced and conditioned while they're in service. The demo is set to unveil in Q4 of 2021, So with this pilot demo, Smartville hopes to prove that our lithium-ion battery hybrid repurposing and recycling solution is effective in reusing and conditioning second life batteries while providing services to the grid. The hub facility can lead to a scalable battery recycling solution driven by economic value and user convenience. To scale up our pilot validation, Smartville aims to build distributed hub facilities in locations across the nation. And the scale of the hub facility is projected to be a gigawatt warehouse-like operation with AI and automation to process this large quantity of batteries. The hub facility also ensures efficiency in reverse logistics by serving as a one-stop location for lithium-ion battery collection, sorting, storage, conditioning, second life reuse, and recycling. Along with the pilot demo happening in San Diego later this year, Smartville is looking forward to also deploying our two full-size hub facilities in Fresno and the Bay Area within the next 5 years. So with that, I would like to thank everyone for listening to my presentation, and I'll open up the floor to any questions if there's anybody.
Thank you so much, Trish. Once again, excellent presentation. We've got nothing but home runs today. Looking at any questions, I don't believe I see any. Caleb, Tim, do y'all happen to see any?
I don't believe there are any at this time.
Okay, great. And remind the audience, if you think of any later on, just feel free to post them at any time. Thank you again, Trish. I really enjoyed that.
Thank you.
And let's see, I will, for now, I'm going to take back over the control. And Lauren, I know Clarios is supposed to come on by 3 o'clock. That's 12 minutes. I don't see them yet.
Sorry, I was double muted. Yes,
all right.
I don't see them either yet.
And we know they're going to be here because we've had a multitude of emails for links.
That's right.
Get on. So I guess should we take a break for now, or do you have anything to add to fill in the time? We've got about 10 minutes.
I don't think I have anything that would fill probably 10 minutes.
Okay.
I did forget to call attention to the handout, though, that was included in today's webinar. It gives a brief overview of the prize, and it also gives a brief overview and description of what our 7 teams are working on, as well as some of the contact information. So very similar to what you're seeing on screen right now that Dawn is sharing, but it's in a PDF form to where you can easily access everything and kind of follow up if you have any specific questions. So again, we're encouraging audience members in industry to engage with our teams as much as possible, because they will be, providing solutions that we hope you adopt as consumers, and we hope that you adopt as businesses and utilize to recover these critical materials and help work toward, DOE's goals of recovery of lithium-ion batteries, as well as addressing some of these supply chain risks and kind of contributing to that mitigation strategy. So just more resources for additional information. We also do update the prize pretty regularly at the herox.com/battery recycling prize website, also shared on your screen right now. And we've been, saving information there since the beginning of the prize. So starting at phase 1. So you can go in and review that phase 1 prize structure and rules and which teams applied, as well as the phase 2 prize structure and rules, and kind of follow along, if you will, the concept development of each team. We'll also be sharing additional updates and opportunities to attend webinars or events, and we hope at one point in-person events where the teams will continue to present on their concepts and solicit feedback, because that's one of our key asks, I guess, from the teams, is to develop these business plans and prove that they are economically viable solutions, because DOE is investing these funds to commercialize these solutions and get them out there as domestic opportunities and solutions for, again, addressing those supply chain risks. So I tried to burn some time, but really only gave us like 3 minutes.
I just send an email, let them know we are ready.
That's right.
So what we could do
Hey,
is,
Lauren, maybe you
yes.
could tell us maybe you can tell us the 50,000 mile high version of the other 3 projects from today.
Sure. Yeah, that is a good idea. We will start with Renewance, who's kind of next on the screen next to Clarios. And this will be a high-level version, as each team does, have some confidential business information that they define. But Renewance is developing, as you can see in the description, a digital platform that tracks and manages lithium-ion batteries throughout their full life cycle. So this is basically a digital marketplace, if you will, that kind of tracks batteries, not necessarily in their consumption, but earlier on in the life cycle, and they have some techniques to potentially assess their state of health and state of charge to understand some of the risks that Lauren Crandon was actually highlighting whenever the batteries are not fully deactivated or yet inert. So they can assess that current state, and then they are uploaded, if you will, into this digital marketplace where consumers can access and possibly purchase for maybe second use based off of their state of health or state of charge, or determine how to continue to move that battery throughout the life cycle in order to get it safely to a recycling facility. So they're kind of filling in some of the gaps, if you will, and in the existing logistics supply chain for lithium-ion batteries, and hopes to reduce some of those costs and nuances. Next on this screen, we have Everledger, and this was Team Portables. They developed a concept called Reward to Recycle, and it's actually a smartphone app that rewards consumers for recycling those smaller consumer electronic appliances. So imagine, if you will, going to Home Depot because you need to buy a new drill and you don't know what to do with your old drill that died, after 5 or 10 years or whatever. And especially based off of experience with lead acid batteries, that you can't just throw that lithium ion battery away, and you don't just put it into the trash. Hopefully, if you didn't know that, you know that now. So Team Portables is proposing a concept to where they would collect these smaller consumer electronics applications and then move them through the supply chain. And they hope to incentivize users with maybe some coupons or other kind of environmental impacts for recycling those devices and specifically the batteries from those devices as well. Let's see, and then
Yeah.
go ahead, Don.
No, go ahead. Go ahead.
Okay, I was gonna say we have one more. The last of the 7 teams in phase 3 is Titan Advanced Energy Solutions. So they are working on they're calling a BATIGO, Battery Market Intelligence Platform, and that is built to generate, aggregate, and connect data. So think of blockchain technologies and collecting data again on batteries early on in their life cycle and tracking them through the logistics process. So their concept also addresses some of the challenges and gaps in existing infrastructure and logistics processes for collecting, sorting, safely transporting, deactivating, and separating those materials to eventually get to the end recycler. I believe they also have integrated, into that process some innovative solutions on also assessing state of health and state of charge, because that process can be a little more technically challenging as well as expensive for the industry. So I'd say in a nutshell, that's the high level view of the 3 other teams who are not able to present today.
Okay, fantastic. I do see Clarion team members are popping on. We'll give them another minute or two because I have just a few questions of my own, and then we'll see who's going to lead off for Clarios. And I may have missed this, Lauren. Forgive me if I did, but when did this competition actually begin?
This began, I believe it was 2018. It seems so
Okay.
long ago now.
All right.
Yeah.
Have an expected end date?
Yes, well, final submission for phase 3 for the participants is April 8th.
Okay.
Our prize structure up until then has included a kickoff event, review of the rules. The teams actually just submitted their progress updates to let the prize administrators know how the development has been going, or if they've, come into any barriers. And the prize administrators have also reviewed those concepts and offered some feedback to help develop the concepts before the final submission in phase 3. And we will also have another industry opportunity for networking with the participants, likely either the end of this year, maybe in the summer, or hopefully early next year. That's normally a collaboration event with NatBat, who is an international association that, if you're familiar, with energy storage and specifically lithium-ion batteries, you're probably aware of NatBat. So that's another event to look out for before our teams finalize everything and submit in April of 2022.
Fantastic.
I have 2 more
And
questions
please,
from the audience.
okay, go ahead.
All right, the first one was, would DOE be seeking input from IT OEMs, auto OEMs, and municipal recycling facilities about these various approaches?
DOE will not specifically be seeking from these specific entities. No, we have the prize administration team is compiled of its own set of reviewers, and those are representatives from different government agencies such as EPA, DOT, we do have DOE, and multiple fields or offices, within DOE, such as Vehicle Technologies Office, as well as Advanced Manufacturing Office, and technical experts supporting from the national laboratories. So we as judges, or the prize administration team as judges, will not be soliciting those feedbacks. We're encouraging teams to gather that input and include it and support their concept solutions with that input.
All right, and another question is, are they accepting batteries from other companies for sorting? And then do they send them for recycling? Or that's a question from earlier. How
No
is Titan's work
worries.
different than how is Titan's work? Yeah, how is Titan's work different than the WEF's Global Battery Alliance Battery Passport?
I am not familiar with WES, so I cannot say specifically. I encourage whoever submitted that question, though, to follow up specifically with Titan AES. Yeah, and hopefully the team will reach out and address some of those questions or gaps or even some of the alignment.
Okay. Well, with that, thank you so much. And it looks like we can begin with Clarios. Now, I see a few names up there, I believe, representing them. Mike, Adam, David. I don't see John, who I thought was going to be the main presenter, but are one of you three going to take this lead?
Yeah, let me kick off. So hopefully
Okay.
everyone can hear me.
Is this Adam?
Yes, my name is Adam Muellerweiss. I'm Chief Sustainability Officer at Clarios, and I have the honor of sponsoring our team's effort and introducing the folks who will be kind of presenting on some of this. We're going to keep it pretty high level and look forward to a dialogue. But before we jump into that, there was a question about the World Economic Forum, the Global Battery Alliance Battery Passport. That is certainly a parallel effort that we are a part of at Clarios, and part of this effort and what we're grateful for is the ability to kind of amalgamate a lot of things that are going on in the world through this very focused effort that the Department of Energy and NREL and others are leading. So thank you for that opportunity, and then also just the opportunity to share with you some of our experts and what we're focused on. But fundamental to what we're trying to do is, based on the business that we operate and where we play. We're the world's largest manufacturer of low voltage batteries for vehicles of all kinds. We have a very expansive and extensive network that allows us to produce lead acid batteries from the lead acid batteries we collect in a circular system, in a circular economy. So in North America, we can collect and use as raw materials batteries from the Arctic Circle to the Yucatan Peninsula, and we do that every day. We also have a lithium ion business that's also serving the low voltage applications and needs of the automakers, and we are looking to identify ways through this project to leverage those two worlds, both the experience and learning we've had in the past from now over 100 years of recycling traditional conventional car batteries to this new world and new technology. So I'd like to introduce David Boone. I'll just run through our team, who leads our global engineering and labs for lithium ion. John Schusterich, who if he's not able to join, I'm sure we'll find a way to cover, but he's our supply chain leader who kind of understands the nexus of these two worlds. And Michael Sendelbach, who's the program manager for this effort, as well as our key lithium ion programs. So I think we had just a couple slides, if we can advance to those. And David, you might be muted, or Don, excuse me.
Doing my mime again. Who would be doing the slides, and I can give them control to share the screen?
Let me see if I have them up. Yeah, why don't you give me control and I will try to bring them up right now.
All right, you should be getting the invite now.
Okay. All right, so just want to confirm that you're able to see
Yes, indeed. I can see it in full presentation mode as well.
Okay, great. So this is really the heart of the concept is, we have at the core what I described as our network and global capabilities, as well as very developed capabilities on the lead acid side in North America in particular. And it's really an opportunity to identify that loop and the opportunities through the various steps that are in this diagram about how we can, if you can use my shorthand that I tend to use, share the bus and do that safely and responsibly, and be able to do that in a way that can be scalable over time. And there's a lot of steps and needs to do that. That's why we are really excited about this prize, because of the need to really advance this space. And that's really what the focus of this team and effort is. So I think John may not have joined us, but David, Michael, I just want to maybe hand it over to you to comment on additional items, and I'd be happy to jump to the next slide for you, where we can talk about the 6 pilot areas.
Yeah, sure, Adam. Why don't you go to the next slide? So, the circle there that Adam showed, we're really focusing on logistics up front that lead into then the back end of the recycling program here. So the network that we have in place that we can leverage to access, pick up, and safely transport used end-of-life warranted lithium-ion batteries. And we're focusing right now on mainly automotive, and as Adam talked about, really the low voltage segment of automotive. And so let me just speak to the 2 pilots here that I'm involved in. I can speak, I guess, quickly to these pilots. That we're working, this pilot number 1, we're working with OEM, OES service centers to see what their needs are, see what types of batteries we can pick up from them, and how we can help them to get those safely transported to their next destination in the recycling chain. We look at the number 2 here, plant scrap. We have our own plant in Michigan that we're going to leverage some of the scrap that comes out of that plant to be able to safely pick up, transport to the next stage of, let's do the appropriate recycler to get that material recycled into back into the metals, the precursors for lithium-ion cathode and anode materials. The third one here is an accident site. So let's say there's an electric vehicle that's crashed out on the side of the road somewhere, and you need to be able to safely go and retrieve that, access that. We're working with multiple companies on that. So I should mention the companies here that we're working with, Environmental Restorations, helping us with the logistics of picking up the damaged. So if it is damaged battery pack from out in the field, Global Battery Solutions, I'll speak more about them. And we end up taking those then to end-use recyclers like battery resourcers or Li-Cycle to then take the materials and reactivate them back into precursors that can be put back out into manufacturing of active materials for lithium-ion batteries. So the 2 ones that I'm actively involved in, these are my other team members. The other team members are involved in those first 3, leading those. I'm leading the number 4 and number 5 here, which both are working on developing technology that can diagnose and monitor and help facilitate the safe transportation of lithium-ion batteries in all aspects of their life, whether they're damaged, whether they're middle of life, end of life, wherever they're going to be transported to the next stage in the process. And those technologies specifically, let's talk about number 5 first. It's a diagnostic device that we're working with a company called Admiral Instruments to develop that can be portable, can be taken to an accident site or wherever it's needed to be taken to, and can quickly diagnose the battery for chemistry, for ultimately state of health and SOC, so that before we ever put it into a package and put it on a truck, we can say and have data that shows that that battery is at that point in time safe to be transporting. And that helps us understand, at that point, what kind of extent of packaging we need, what extent of precautions that we need to take to be able to safely transport that battery to to the next stage. Backing up to number 4 there, the intelligent cell technology that we're working with Global Battery Solutions on is making our packaging, in effect, a smart package, which has the ability to, inside the packaging, monitor key parameters such as temperature inside the packaging. And if there is a upper threshold that's exceeded for a certain temperature that's indicating that there's been an event inside that packaging, then if it's on a truck, then a warning will be sent Bluetooth to the driver of the truck or local responders nearby, whoever we deem that necessary to be sent to, that then they can pull the truck over and react accordingly, knowing that they've got an issue going on, and get it into a safe area where it won't be as damaging or life-threatening to other people. So that's the 2 main ones that I'm working on. The number 6 that John was going to speak to has to do with that packaging design. And you see there we're working with Heritage Company, we're working with environmental restorations. I should mention another one in there, Cooler. And all of those efforts in this number 6 pilot are leaning towards how to go pick up a battery that needs to be picked up, determining its state of health, diagnosing it, putting it into a safe package. That's where Cooler comes in. That's where Heritage comes in. Environmental restorations helps us with that. And then the packaging itself has some suppressing characteristics to it. If there is an event, it prevents it from propagating to other packages, other battery packs in the same facility, in the same truck. And then using the 4 and 5, that we diagnose it, we then can monitor it as we go down the road, ultimately getting it to whether it's going to be an end-of-life use facility, some sort of sorting facility, or heading them to the recycling program person so that they can then reclaim the valuable materials and move them into their next portion in the life cycle here. So all of those have active pilots going on. We're going to actually trial our processes through each one of these steps and show that our overall concept is feasible using our logistics network, using these technologies from these different sites where we might pick up materials, and so that we can safely facilitate the transportation of lithium-ion batteries, whatever their state, to their next point in their life. Okay. You're on mute, Adam.
Sorry, I had a separate mute button. Thanks, David. Maybe I'll just quickly recap with a couple of comments and then ask Mike if there's anything we missed. But if you could sum up our view, these 6 pilots are the critical things that we think are needed, and breakthrough is needed to be able to safely and responsibly use this closed loop that is available and certainly capable of doing much more. And to do that in a way that is first starting with a smaller scope of products and solutions, but is extendable. And this is really based on our experience in looking back on how did we get to almost 99% or more recycling of lead acid batteries in this network. And there are a lot of drivers, and there's some of the economic drivers that we haven't talked about in this that we hope some of these pilots will help unlock. But it was a key learning that you could not do it alone. You couldn't do it alone as an individual company that manufactures batteries, as a logistics company, as an environmental service cleanup company, as an OEM, as a government looking to regulate and find the right balance of solutions to be protective, but also enable a circular economy to grow and become viable. So it really takes an unprecedented level of collaboration. We had the benefit of generations before us within Clarios to develop that on the lead acid side, and that's really what, if you could put it in a nutshell, we're trying to do with these pilots is extend out to a group of very capable and willing partners to see what we can do with these 6 pilots, and really look forward to the work maturing as we move forward. That's really what we wanted to share with you. But before we maybe hand it over, Mike, I just want to make sure we are not missing any other key points that you would like to share.
No, I think you guys did a super job of explaining it. So I would just as soon throw it open to questions if you'd like.
Sounds good.
Fantastic. ESI staff, do you see any questions being posed at the moment?
I'm seeing no questions for this last presentation, but there is a general comment from Holly Elwood from the EPA, who says that we're happy to connect the prize winners with the Suppliers Partnership for the Environment, a trade association for sustainability efforts in the auto sector, to help them possibly get input from auto OEMs on their approaches. And the email would be elwood.holly@epa.gov. And we can also send that to anybody interested.
We would certainly appreciate that. We are also very close and participate in the Supplier Partnership for the Environment. And as I mentioned earlier, there's a number of complementary efforts that we are a part of as members of the Responsible Battery Coalition, working with OEMs and aftermarket retailers on best practices and some research around the circular economy of batteries of all chemistries. The Global Battery Alliance that was mentioned earlier, which is really starting to look at chain of custody and some of the battery passport concepts that may be applicable, and are leading some efforts there. Some of the great work that's been done by the US EPA and helping to establish the underlying frameworks and regulatory constructs that allow us to collect and transport batteries today, as well as working with some of our partners on some of the emerging issues and challenges of recycling lithium ion and various chemistries around the country. So we would welcome any additional feedback. I would say that this is an incredibly important project for us at Clarios. It has a very defined scope, which we're looking to really push forward with the objective of trying to find a breakthrough opportunity, which we believe leverages a strength that is unique for us as a company, but also for us as a country and a region within North America. But certainly the Supplier Partnership for the Environment is one we know very well.
Fantastic. Any other comments or questions?
One more question came in while you were talking there. Can you talk about how feasible it is to process EV batteries and other lithium-ion batteries at existing lead acid battery processing facilities?
So it's a good question, and probably I was remiss to note that they can't be done. So what is actually critical is to avoid commingling of the two chemistries. There can be actually significant danger and harm and risk of potential thermal events if lithium-ion batteries are processed in the same furnaces and breakers and processing equipment that processes lead-acid batteries today. What we see as an opportunity is more importantly the logistics network and capabilities and what is required to share the bus, as I mentioned. So you can commingle and safely identify, render safe, test, and transport these lithium-ion batteries through our network to very specific different technology, different solution providers to process them. So that is a good question. At this point in time, there's no foreseeable solution that would allow you to process everything in one big black box. but there is a significant potential we see about using the existing network that is in place from a logistics perspective, and then also learning what it took to get to the kind of recycling rates we have in the conventional automotive battery space. It should also be noted that there was a lot of variability even in the lead acid battery space when we look backwards, that there wasn't this one size fits all ability to recycle with the networks and recycling centers that exist for our products, competitors' products, et cetera. That evolved over time. And so, this through the 6 pilots and other initiatives is really focused on a deliberate, intentional way to identify how we could get ahead of this and maybe learn from the past to accelerate a lithium-ion network at scale in the United States.
Fantastic. Well, if anyone comes up with any more questions, comments, feel free to please let us know. If any of the teams have any comments, questions, or experiences to share amongst each other, please feel free to unmute and we can discuss that as well. But otherwise, we're at the conclusion of the event. Lauren, do you have anything else to add?
Yeah, I'm just encouraging, again, the audience members to go to the website, theherox.com/battery recycling prize, to follow the prize, because again, we're going to be organizing more events to help connect the teams with different industry to solicit this feedback. And Holly, I actually took an action item to follow up with you, and maybe we can arrange something with EPA to where the teams can go in and present specifically. So more of a just heads up, go follow the prize, and hopefully we have more opportunities to hear from the teams, and that the other 3 of our 7 teams would be able to present as well.
Well, would this be a good point to conclude?
I think so. Thank you for our teams that have volunteered to attend. This was not a mandatory event for the prize structure, so we appreciate you taking the opportunity to present on your concepts and solicit the feedback.
Okay. And as you can see, there will be a post-webinar survey for your feedback when you exit. Please take a few minutes to complete it, as it helps us improve not only the ESI, but also make sure that we are offering information topics in which you are interested. And as I noted at the beginning, an email will be sent, and you can also check out our website, www.ncesi.org. I also include that in the chat box, but feel free to check that out for the webinar materials and a recording link. Thank you, everyone. Lauren, it's been fantastic. If we can keep in touch, I'd love to find out the end results of this, and we can help you market that as well. Be more than happy to do that. We do a bi-monthly ESI news, etc., and so we'd be glad to help you market that and promote this as much as possible. So we'll definitely stay in touch. But thanks again, everyone, for attending. I wish you good health to all, and have a fantastic day.
Great. Thanks, Don. Thanks, everyone.
All right.
Bye.